Hello, my champions. I assume that you know about triangles. Okay, triangles means three-sided figures. No, it's something like these, right? And you also must have learned about different types of triangles based on their length, based on their angles, right? If you can identify what kind of triangles these are, that would be great. Okay. However, let me identify it for you and see whether you have got it right. The first triangle is what kind of a triangle? It's a right angled triangle because there's a right angle here, isn't it? And it is not, all sides are not same and all, it's different. So we cannot talk about it. It's a scalene triangle. It's not, nothing is equal. Okay, if we come to the second triangle, if you see this particular side and this particular side is same, so two sides are same, that means it's an isosceles triangle, isn't it? Okay. If you see the third one, it's again a scalene kind of a triangle. Scalene triangle, it's not even having a right angle. Okay, scalene means none of the sides are equal to each other. Okay, so the topic of this video is not about the types of triangle. That is in another video on my channel. However, in this video, we're going to talk about the perimeter and area of a triangle. Now, perimeter, we know what is the meaning. Perimeter means it's a boundary, the length of the boundary. Similarly, for area, what is the meaning? What is the space inside that boundary? That is called as the area, right? Okay, now let's come to this and try to find the perimeter, perimeter of this, these triangles first. Okay, that is very simple. You just have to know the side lengths. What are the side lengths? Here the side length is 4, the side length is 2 here. And using the Pythagoras theorem, you're going to find this other side, that is going to be 2 square plus 4 square. And this one, this one is going to be root of 2 square plus 4 square. That is 16 plus 4, 20, that is root 20. So the perimeter of this triangle is going to be 2 plus 4 plus root 20. That is nothing but 6 plus root 20. Right? Yeah. Is there a formula for this? Nothing. You just have to add them up. That's it. Now, perimeter for this triangle, isosceles triangle, let's say this is 4 here, and I'm not having any measurement here. Okay, we can take a scale and we can measure them. But how? I'm not going to do that. What I'm going to do is first, you take this side, you take this side, and just add them up. Let's say this is some S, so this is some S, and you're going to just add them. That's it. That is going to give me the perimeter. There's no requirement of any specific formula is not there for a triangle's perimeter. If it's an equilateral triangle, then we can say, even if you know only one side, you can say this also will be A, this also will be A. So it will be totally the 3A, perimeter will be 3A, right? And if I come to this, length of this side, length of this side, length of this side, if I add all these things, that time I get the perimeter. That's all. There's no I formula for this perimeter of a triangle. Okay, not required also. Perimeters, just count the boundaries, right? Count the length of join the length of the boundaries you're going to get. Okay, so that's it about the perimeter of the, triangle. Now let's talk about the area of the triangle. Okay, that's a little interesting part because you'll understand how we can find out area. Is it, is there something that we can have common? And that is what we're going to find out. Okay. Okay, let it be any kind of these triangles. Okay, what I can do is I can convert that into rectangle. How? I'm going to take a mirror of it basically. I'm going to, do a mirror kind of a thing. Means this rectangle is there. No, I'm going to make a rectangle out of this. I'm just going to mirror this. If you see this blue color line is a mirror of the existing thing. And if I'm doing this, can I do the mirroring of this one here? Okay, I'm going to convert this also into, okay, let me do, okay, I'm going to do a mirroring kind of a thing here and I'm going to put it here. Okay, so what happened exactly, which is just, it's tilted. Can I do the mirroring here as well? I can do, I think. Okay, what I can do is I can go till here and I can do like this much. Okay, I can do this kind. So what I've done is I've tried to change mirror them. And then now what I'm going to do is I am going to cut this thing, right? I'm going to cut this thing till here. And whatever is there here, I'm going to put it this side. That means finally I get this much and this much. So the final thing that I'm going to have is the pink color one, that is this line. That is the final thing, right? And similarly, so this is not there now. This is not there because I have moved it to this place. I have moved it to this place here. Right. And this one is direct. So the entire thing for this is a rectangle here like this. Okay. And can I convert this into a rectangle again? I guess what I can do is I can just cut this part and put it this one here. So that will fill it up properly. So I'm going to get something like this, a rectangle. Wow. So this is not there now. This is not there. This is not there. And okay, that is what I have got. Of course, you might be wondering, oh, okay, this became extra, no? Something became extra, isn't it? Initially the triangle was this much only. This was our triangle. This was our triangle. And now it has become doubled. This other thing has come. Initially, our triangle was this. This is, okay, let me draw in a different fashion. This extra things, I'm going to do it in dots. Okay, the extra things is going to be in dots. So this is extra, this is extra, this is extra. And if I see here, this is extra and this is extra. And this was our existing triangle that we were seeing, right? Okay. So now we know the area of a rectangle already, right? We know that formula. What is the area of a rectangle? Area of a rectangle was the length multiplied by this breadth, right? So the length multiplied by this breadth gives me the area of this rectangle. But then we know the area of this rectangle is length in, but rectangle is a full pink color. But I don't want the entire thing. It's half of it. If you see this, the dotted area and the lined area, they're half of it. So the area is half of it, right? Similarly, coming to this, compare the dotted area and the lined area. If you see, they will be half. Again, the length is here and the breadth is here. So it will be half of that length times breadth. Similarly, here also, if this is the length and this is the breadth, okay. So the area is again going to be, look at this, the dotted area, the lined area, this is going to be half of length times breadth. Wow, there's a pattern here, right? There's a pattern here we have got. Okay. Now only now what I'm going to do, I'm going to remove all the extra things, extra stuff I'm going to remove. Okay. Extra stuff I'm going to remove. The blue color is our what do you say? The rectangle that we try to draw, the mirroring that we try to draw, right? So I am going to remove all of that. Mirroring that we try to draw. And the breadth that we were talking about was this exact length, this length, right? This length was the breadth. And the breadth that we're talking about here is this length. And the breadth we're talking about here is this length, right? Okay, the breadth, this is called the breadth. Now, if you see, the blue color is not our triangle, the black color is our triangle, right? And if you see all of this length, whatever we talked with respect to rectangle is same as something that was there in the triangle also. In a triangle where we have something, the line, at the bottom, this bottom line, we call it as a base. If you see here, these lengths are all base. There's a base of the triangle, there's a base of a triangle, there's a base of a triangle, right? So we can say the area in the place of this length, I'm going to write base of a triangle, the triangle. Then what can we talk about? The breadth here, right? So look at the breadth here. This breadth, it's a vertical line, exactly standing straight at 90 degree it is standing, right? Look at this line also. The breadth in the second figure also is a vertical line exactly at 90 degree. And even the third figure, the breadth is a line exactly at the 90 degree. Right? Exactly at 90. So this exactly at 90 degree on the base, if this is the base, whatever line is standing on the base exactly at 90 degree, and that is going till the tip of the opposite vertex. Opposite vertex it is going. That means a line. Okay, what I'm going to do now is I'm going to erase all of this, and the same breadth, whatever this line was there, whatever this line, the breadth was from here to here. So just imagine I am going to move this line towards here. And if you see, that will exactly stand in this place and stand in this place. On the base, it is standing at 90 degree, it is standing and it is touching the opposite vertex. If I move this baseline also, if I'm going to move this baseline also, if I'm moving it like this, it will stand on this base and it will stand at 90 degree and it is also touching the opposite vertex. Okay, this one need not be done. It is already like that. This base is already standing. This base is already standing in this on this base, this line, and it's standing at 90 degree and it's touching the opposite vertex. Such a line which is standing on the base, it is standing on the base at 90 degree and the other side is touching the opposite vertex. Vertex is called as the height. So what did we see? Let it be any kind of a triangle, right angle triangle or a isosceles triangle or a scalene triangle, whatever be the case, the triangle, the area of the triangle is given by half times the base times the height. That means you take any triangle. If I'm taking this as my base, there should be a 90 degree line standing on this base and touching the opposite vertex. That length will become my height. This length will become my base. If I consider the other line as my base, okay, let's say I'm not consider this as a base. I'm going to consider this side as my base. Okay, if I'm going to consider this as the base, then I will have to draw a line which is 90 degrees standing on this base and touching the opposite vertex. Then this becomes the height. This is how I'm finding the area of a triangle. Okay. I hope you understood how the triangle's area comes, right? There are many other ways also to find areas of a, equilateral triangle and other ways using perimeter. However, most of the times, the one formula that is always used is this: area of a triangle is half times the base times the height. And the very important understanding that you need to have is what is the meaning of this base and what is the meaning of this height. Many a time students get confused about this and they don't understand what is the meaning of this height and they make a lot of a mistake because of that. Okay, so you need to understand what is the meaning of the things in the formula. You're just not mucking up the formula. And math champions do not do that. They always learn what, how, why, right? I hope you've understood how the triangle's area comes. What is the perimeter? How do we do it? Go ahead, try to solve some problems on your own and enjoy learning mathematics. I'll see you in the next video. Until then, see you. Bye-bye.